Hi, welcome to Math Maxtra. This is Sarita. Today in this class we will discuss about transversal lines. So transversal lines. What is a transversal line? See, if you take any two lines, two or more than two lines, you take another line. If this line intersects those two or more lines in two or more distinct points, then we call it as a transversal line. You see, this is one line. We call it as a L, and this is another line. We call it as M. So you are taking another line, another straight line, which is intersecting these two or more lines, two lines in two distinct points. So this is point P and this is point Q. So this is the line, this intersecting two different lines in two distinct points. Then we call this line as a, let us take this line is a Q line. So this Q line we call it as a transversal line. Okay, this is what a transversal line. We'll see what are different types of figures, whether they are forming a transversal line or not. See, you check this figure and okay, these are three lines. Okay, L, M, N, and see this line, whether it is a transversal line or not. See, check whether this P line is a transversal line or not. This is intersecting these three lines in three distinct points. So three lines L, M and N at three distinct points. That is why this is called a transversal line. So this is a transversal line and this is also a transversal line. Okay, and we'll see the next figure. You tell me whether this is a transversal or not. And this is the line L, this is the line M, and this is the line P we are drawing, and this is intersecting these two lines. You tell me whether this P line is transversal or not. Obviously not, because in the definition itself I said you this line must intersect two or more lines in two or more distinct points. Yes, but it is intersecting these two lines at the same point. See, this is the common point for both the lines L and M. This P is intersecting these two lines at the same point. That is why this is not transversal. So P is not transversal. So P is not a transversal line. And you see one more figure. These are two straight lines L, M, and you take this another N. You tell me whether this P line, is a transversal or not. It is not a transversal. Why? See here, these are the two different lines, but they are intersecting at a common point, and this is although it is another line, but these two lines are intersecting at a common point, and this is a line which is passing through the common point to those two lines. That is why this P line is not a transversal. It is not a transversal. It is not a transversal. So in this way you can identify what is a transversal line. Yes. Okay. Now because of this transversal line, this is the line L and this is the line M, and this we are taking as a transversal line. Okay, because it is intersecting these L and M lines in two distinct points. That is why, so this P line is a transversal line. That is fine. This transversal line is making different angles at the intersecting point. See, this is one angle it is forming, this is another angle, and this is another angle, this is another angle. At one intersecting point, it is forming four different angles. And in this also, it is forming one angle, and this is another angle, this is another angle, this is another angle. So these 8 angles means with the two lines, one transversal line is forming 8 angles. But what are those angles? What is the classification of angles and how we call them? So we'll see now. These are different angles. We call it as, this is the angle 1, this is the angle 2, this is the angle 3, this is the angle 4, and this is angle 5, angle 6, angle 7, angle 8. Okay. So these are 8 different types of angles thus formed because of a transversal line P. Now we'll see what are the classification of angles made by a transversal line. So classification of angles. The first type is interior angles. Interior angles. What are interior angles? In order to say the two lines are interior angles, those two angles must lie between the two lines L and M. See, these are two lines L and M. So the angles, in order to say the two angles are interior angles, those two angles must lie inside of these two lines. Inside of these two lines. You see, what are the angles inside of these two lines? Angle 4, angle 3, angle 4, angle 5, angle 6. These are all interior angles because they lie inside the two lines L and M. See, what are the interior angles? Angle 3, angle 4, angle 5, angle 6. Yes, these are interior angles of a interior angles formed by a transversal. Okay. The second case is exterior angles. Exterior angles. What are exterior angles? See, in order to say the two or more lines or angles are exterior, they both the lines, sorry. In order to say two angles are exterior angles, in order to say both the angles are exterior angle, they must lie outside of the two lines. They must lie outside of the two lines L and M. See, the angle 1, angle 2, angle 7, angle 8. These are exterior angles because they lie outside the lines L and M. What are the exterior angles? Angle 1, angle 2, angle 7, angle 8. So these angles are exterior angles. Okay. The third type is Co-interior angles. Co means lying on same side. In order to say the two lines are co-interior angles, those two angles must lie on the same side of the transversal line. See, check. First, take two angles. Those two must be inside the two lines. Then only we call them as the interior angles. So what are the angles we take? Those must be interior angles first. So what are interior angles? Angle 3, angle 4, angle 5, angle 6 are interior angles. So in these interior angles, the angles which lie on the same side of the transversal. You check, this is the transversal. So angle 3, angle 6, both are interior angles as well as they both lie same side of the transversal. That is why we call these two angles as a co-interior angles. So same side of the transversal. Angle 3, angle 6 are co-interior angles. Those as well as angle 4, angle 5 also lie on the same side of the transversal. Those also interior angles. That is why we call them as a co-interior angles. So angle 4 and angle 5 both are. This is one pair of co-interior angles and this is another pair of co-interior angles. And this next case is co-exterior angles. Co-exterior angles. What are co-exterior angles? Similarly, so first we take exterior angles. So what are the exterior angles here? Angle 1, angle 2, angle 7, angle 8. The four angles are exterior angles. In those four angles, what are the exterior angles lying on the same side of the transversal? See, angle 2, angle 7, they both lie on the same side of the transversal. That is why we call these pair of angles as a co-exterior angles. You see angle 2 and angle 7, these a pair of co-exterior angles. As well as check angle 1, angle 8. These are also exterior angles as well as they lie on the same side of the transversal. That is why we call them as a co-exterior angles. So these are the co-interior angles and co-exterior angles. And the next type is allied angles. Allied angles. The pair of angles which are they are either co-interior angles or co-exterior angles. We call them as a allied angles. So they may be co-exterior, they may be co-interior. So those angles are called allied angles. See, so we have to write all this pair of angles. These are co-interior angles. These are also allied angles. And these are co-exterior angles. These are also allied angles. Okay. Angle 3, angle 6 is one pair of allied angles. Angle 4, angle 5 is one pair of allied angles. Angle 2, angle 7 is one type of allied angles. Angle 1, angle 8 is another type of allied angles. Okay. So these are allied angles. And the next case is corresponding angles. So next one is corresponding angles. What are corresponding angles? See, the angles, in order to say the two angles are corresponding angles, it must satisfy three conditions. So what are those three conditions? So the first condition is the angles we consider must be lie on the same side of the transversal. So must be lie on the same side of a transversal. And the second condition is they see, you check what are the same side, what are the angles which are same side of the transversal. Angle 1, angle 4, angle 5, angle 8. These are same side of transversal, as well as angle 2, angle 3, angle 6, angle 7. These are lie on the same side of the transversal. Okay. So the second condition is those two must be one interior and one exterior angle. Thus two, whatever the angles we consider, in those one must be interior angle, one must be exterior angle. You check, this is the exterior angle, this is the interior angle, this is the interior angle, this is the exterior angle. So in those, one angle must be interior, one angle interior, and one angle exterior, one angle exterior. You check, see, this is angle 1 exterior, angle 4 interior. Can we say these two lines are corresponding angles? No. So one more condition is also there. Those two angles should not be adjacent angles, or they should not have any common arm. See, this angle 1 and angle 4 have a common arm. This is the common arm of these two. That is why these two are adjacent angles. So they should not be adjacent. That is why we should not consider this combination as a corresponding angle. So we can, you take this one. See, this is exterior angle. This is interior angle. Okay, fine. The first condition is satisfied. And one is, see, both lie on the same side of the transversal. See, angle 1, angle 5, both lie on the same side of the transversal. As well as the third condition, they should not be adjacent. See, this angle 1 and angle 5 are not adjacent angles. So we can call them as a corresponding angle. So angle 1 and angle 5 are. And the third condition is should not be adjacent angles. Should not, otherwise should not have a common arm. So these are the three conditions in order to say the two angles are corresponding angles. We'll see the examples of corresponding angles. Example, see, angle 1 and angle 5. This is one pair of corresponding angles. And angle 4, angle 8. You check, see, angle 4 and angle 8 are lying on the same side, as well as one is interior, one is exterior, and they are not adjacent. So three conditions are satisfied. So we can say angle 4 and angle 8 are corresponding angles. Angle 4 and angle 8 is one more pair. And check this side, angle 2, angle 6. Angle 2, angle 6 are corresponding angles. Angle 3, angle 7 is also one more pair of corresponding angles. So these are examples of corresponding angles. Okay. And we'll see the next type of is alternate interior angles. The next type is alternate interior angles. Alternate interior angles. See, in order to say the two angles are alternate interior angles, so the first thing they should satisfy is the both the angles must be interior angles. See, check, angle 4, angle 5, angle 6, angle 3, these are all interior angles. Okay, fine. So the first condition is must be interior, must be interior angles. and those interior angles must lie on either side of the transversal line. So the alternate, the name itself, it is telling that those two angles must lie on either side of the transversal. See, angle 4, angle 6, both are interior, but angle 4 is lying on that side, angle 6 is lying on this side. So the second condition is must lie on either side of the transversal, either side of transversal. And the third condition it should satisfy is they should not be adjacent angles. See, this is both are interior, both lie on either side of the transversal. Can we say angle 3 and angle 4 are alternative interior angles? No, because one more condition it should satisfy, they should not be adjacent angles, means they should not have a common arm. So this is the common arm of angle 3 and angle 4. That is why we don't call them as a co-interior, alternate interior angles. That is why you check this combination, angle 4 and angle 6, both are interior, both are lying on either side of the transversal, and they don't have any common arm because they are not adjacent. So the third condition is should not have a common arm. Should not have a common arm. So these three conditions in order to say the two angles are alternate interior angles. See examples, angle 4 and angle 6, these are alternate interior angles. Examples, angle 4 and angle 6, these are alternate interior angles, as well as angle 3 and angle 5, these are alternate interior angles. Yes, okay. The next one, alternate exterior angles. Alternate alternate exterior angles. In the alternate exterior angles, here the two angles must be exterior angles. So both the angles must be exterior angles and they must lie on either side of the transversal. See, check angle 1, angle 2, angle 7, angle 8. These four angles are exterior angles. Yes, okay, fine. They must lie on either side of the transversal. See, angle 1, angle 7. Angle 1 is that side, angle 7 is this side. Okay, both are either side of the transversal and they should not have any common arm. Yes, angle 1 and angle 7, they don't have any common arm. That is why we can say angle 1 and angle 1 and angle 7 are called alternate exterior angles, and angle 2, angle 8 is also another pair of alternate exterior angles. Okay, so these are different types of classification formed by a transversal line P, and we'll check one more. You check, see, these angle 1 and angle 2 are adjacent angles or not? Yes, these are adjacent angles. Whether these sum of these adjacent angles 180 degrees. Yes, the when we draw a transversal line, always in the always adjacent angles are supplementary angles. See, angle 1 and angle 2 are adjacent angles. Angle 2, angle 3 are adjacent angles. Angle 3, angle 4 adjacent angles. Angle 1, angle 4 adjacent angles. So, there is a combination of all this. And here also, angle 5, angle 6 are adjacent angles. Angle 6, angle 7 is also adjacent angles. Angle 7, angle 8 are also adjacent angles. Angle 8 and angle 5 are adjacent angles. So this many types of adjacent angles it is forming. So in this case, the sum of adjacent angles is always equal to 180 degrees. Means in the case of transversal, adjacent angles are supplementary. Adjacent angles are supplementary. Means sum must be equal to 180 degrees. So the sum of angle 1 plus angle 2, which is equal to angle 2 plus angle 3, which is equal to angle 3 plus angle 4, which is equal to angle 1 plus angle 4. All these sum is equal to 180 degrees. Okay. So similarly, angle 5 plus angle 6, which is equal to angle 6 plus angle 7 plus angle 7 plus angle 8, which is equal to angle 8 plus angle 5. This sum is also equal to 180 degrees because adjacent angles are supplementary in case of transversal line. And the next one, see, you check this angle 1 and angle 3. What we call these two angles, Isaac? Vertically opposite angles. Because see, this is one line. Okay, this is one straight line and this is another straight line. These two straight lines intersecting at this point. So, when the two lines are intersecting, we have seen in the last class, they form a vertically opposite angles. So, angle 1 and angle 3 are vertically opposite angles. Angle 2 or angle 4, angle 2 and angle 4 are also vertically opposite angles. So, what is the condition? Always vertically opposite angles are equal. That is why here vertically opposite angles, angle 1 is equal to angle 3 and angle 2 is equal to angle 4. Here in the similarly in this case also angle 5 is equal to angle 7 because those are also vertically opposite angles, as well as angle 6 is equal to angle 8. These are also vertically opposite angles. These are the different types of angles are formed by a transversal line P. So we will discuss about intercept and corresponding angle theorem in the coming video. Thank you.